Often it can be difficult to calculate probabilities of outcomes or events exactly. But there's one situation where there is a nice easy way to do it, and that's what we're going to talk about in this lesson. So we'll begin with an example of this situation, and then we'll say what the general rule is. So our example is our favorite example so far, a die roll. So we've looked at this from various points of view in earlier lessons. So remember that the sample space is the set consisting of 1, 2, 3, 4, 5, and 6. These are the possible outcomes when we roll a die. Now, suppose that we want to calculate the probability of just one of these outcomes. For example, let's say that we want to calculate the probability of rolling a 6. Okay, so what do we know about probabilities? Do we know anything that could help us work out what this number is? Well, we've seen in an earlier lesson that one key thing about probabilities is that if we add up the probabilities of all the outcomes, we get 1. So here's that fact written down as an equation. The probability of a 1 plus the probability of a 2 plus the probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 equals 1. The sum of all the probabilities of the outcomes is 1. Okay, well that doesn't get us there yet because unfortunately all of these probabilities are unknown as yet. So we just have one equation and we have at the moment 6 unknowns. However, a die roll is a special situation. If the die is fair, then we'd expect that the probability of a 1 is the same as the probability of a 6, and the probability of 2 is also the same as probability of 6, and so on. We'd expect, in fact, that all of the outcomes have the same probability. So let's write this down. So given that the die is fair, the outcomes should be equally likely. They should all have the same probability. So this means that the probability of a 1 is the same as the probability of 6. And the probability of 2 is the same as the probability of 6. And this should hold for all of the outcomes. So that means that in this equation here that's written in green, in fact, there aren't really 6 unknowns. That all of these unknowns are actually the same, so there's just one unknown. So we can replace the probability of 1 with the probability of 6. We can replace probability of 2 with probability of 6, and so on. So the equation in green actually becomes this: the probability of a 6 all of these probabilities are the same, and they're all the one that we're looking for. So what do we have? We have 6 times the probability of 6 there. And now just divide by 6, and we get that the probability of a 6 is 1 over 6. So you see, we've actually calculated the probability that we were looking for. And the assumption that we used was just that the outcomes were equally likely. Okay, so that's an example. Let's write down the general rule. So in general, we have this, that if the outcomes of a trial or experiment are all equally likely, then that the probability of any particular outcome is just 1 divided by the total number of outcomes. And you can see that's what we got in the case of the die roll. There are in total 6 outcomes, and the probability of any one of them is just 1 divided by 6. So this is an important fact to remember in the situation when the outcomes are equally likely. Let's look at another example. Here's another example of a situation where the outcomes are equally likely. And the question is, what is the probability of drawing an ace of spades from a standard 52 card deck? Okay, well let's look at the sample space first. So rather than writing down all the cards in the deck, I have a picture here of the cards of a 52 card deck. So this is a standard deck of playing cards. So the key point here is, well, how many are there? Well, the answer is clear. There's 52, right? It's a 52 card deck. So there are 52 possible outcomes, and they're all equally likely. The likelihood of drawing any one card from the deck is the same as the likelihood of drawing any other card. Then it becomes clear what the probability of drawing an ace of spades is. So the total number of outcomes is 52. So according to our general rule here, that means that the probability of any one particular outcome is 1 over 52. So that means that the probability of drawing an ace of spades is 1 over 52.